Yo, what's up? What's up? Welcome back. Today we are working on my QR code scanner, kind of. So we're actually looking at hierarchical clustering algorithms or just clustering algorithms in general. But the motivation is we're working on a QR code scanner. And so, for context, where we're at right now is we can successfully find and iterate the modules of a QR code. Where modules is like their word for block, essentially. And this involves some amount of I don't want to say intelligence, that's too strong, but there's some non-trivial work here where a QR code is embedded in this larger image, right? So if I look at the outline of this thing, it's not like the full thing, right? And so we need to figure out what the bounds are of our QR code. We do this thing where we do 1D scanline walks. So these red dots are kind of saying, hey, this is where I think the corner could be, and the blue lines are saying, hey, here's, or the blue dots are also saying the same thing, but from the perspective of horizontal iteration and vertical iteration, right? And then we find these sections where they kind of intersect, and we say okay, that's probably the center. Another thing we do is we look at these timing codes and we walk from left to right and we say okay, so we expect alternating black, white, black, white, black, white, and we want to find out, okay, so what is our module size given this iteration? Because we kind of have a guess from the finder size, but as the image gets really big, that initial guess based off of this small amount of data in the corner starts to get a little off, so we have to adjust it according to that. And so what I want to start looking at is I want to start looking at scanning a QR code in the real world. And now all of a sudden some of our assumptions break down, right? We're kind of assuming that we can look for this finder pattern and we'll only find it in the finder, but that's not true anymore. You might see that pattern for because there's sensor noise, you might see because there's something else in the background, and so now we have to think about okay, we might have some outliers that aren't really what we care about. How do we discard those? Or for things like color, right? Say you have an image that you took of a photo, like a QR code at a bar. I Googled QR code image bar menu and came up with this. So this is an idealized version of a QR code at a bar. It's on maybe a wooden background, but it's pretty ideal. And you can see here, you have this distribution. This is a histogram on the right side here, where basically the height at a given distance into it is how many pixels are that bright, right? So on an ideal QR code, you would see 100% at white and 100% at black and nothing in the middle. But my camera sucks, so I might it might be dark and it might have a bunch of sensor noise on it. So if I start doing something like this where I say, hey, my camera's gonna have some sensor noise on it, and maybe it's also gonna be kind of dark outside, so, or sorry, not dark outside, dark in the bar, so where's this colors, curves, maybe it's gonna look kind of more like this or something. Maybe let's desaturate it first. I find it easier to work with in black and white. So how do we saturation, black and white, then curves? Maybe it'll look, I don't know, something like this. Sure, it doesn't fucking matter. Right? Now all of a sudden, what is determined light and what is determined dark is really hard to understand, right? If I look at this is not really clear. And so you could do something, you could say, oh, well, maybe we blur it a little bit to try to get some of the get rid of the speckly pattern. So you could do something you could do a, maybe a Gaussian blur just to smooth it out a little bit. Let's get it it's a little too much. Can I go to 0.5 or something? Right? And now you see our histogram is again more confusing. How do I determine what are the lights and darks? And so I want to find some way to identify, okay, so probably if I select, oopsies, cancel. Let's if I look at this area here, that's probably dark. And if I look at this area here, that's probably light. And so we need to look at this total histogram and try to identify what we care about. And you could imagine this is in one dimension, but if this is a full color image, maybe we would want to do this in 3 dimensions, right? Maybe we have RGB channels, and maybe your QR code is alternating between red and blue instead of black and white. Maybe that's out of spec, maybe it's not, right? But maybe you want to determine, okay, so one of the colors is red, one of the colors is blue, and so we need to find some way to take our samples, turn them into points. And so same with the timing patterns. You might have outliers in your walk here, right? So as I went white, dark, white, dark, white, dark, white, dark, maybe I make a mistake somewhere. And so I need to say, let's discard that mistake and only average the ones that we think are good. And all of these are kind of the concept of taking real world samples, discrete number of samples, and turn them into like groups. So we're looking at clustering algorithms. And so what we have right now is we have this like program that we've written that can generate clumps of data, kind of. So here I've got, I can say, hey, I want 100 points that are in 7 clusters, and the cluster radius is 3 wide. And we have the like world's simplest clustering algorithm implemented, where you do some amount of steps. Maybe let's do 20 more. And eventually you start getting like clumps of data, right? So these guys are all blue, these guys are all light blue, these guys are all pink. Great. This is just going and saying like, I'm going to look at like the 2 closest together and merge them into one cluster over and over again. And that's one option. And so I want to look at the different options, kind of like different like categories of clustering algorithms. So there's like, this one is hierarchical. There's another one, hierarchical clustering algorithm, that starts with everything in one cluster and splits them up. That's what I want to look at first today. There are some that are like k-means clustering. You start by like looking at a few different areas and then trying to like push your guesses into like the right area. There's like some like density based ones and some like statistics based ones, and I want to get a feel for like what like the common algorithms are, so that maybe we can apply one of those common algorithms to our situations, or we can maybe adapt them to whatever makes sense for us. Maybe we won't end up using any of them, right? It's just I want to get a feel for what's out there. So that's what we're working on. Big intro, but I feel like the context makes it a little more interesting. And yeah, I think the plan today is, right now we only support one clustering algorithm, this like agglomerative clustering, I think that's what it was called. And so we need to have some way for like our UI to say, hey, I want to pick which clustering algorithm I want to try. And then we can implement divisive clustering. And then if we get through all that, we'll just jump onto a second, like another one. I guess maybe it makes sense to go over, before we start, divisive clustering. I'll probably go, I'll go over it a little later when we actually start implementing. Because, yeah, I think it'll make more sense there. Okay. So, let's go into our application section. So the way the code is structured is we have like a server, which is like handling transfer of data between server and client. Client's not doing anything, he's just drawing the dots. And then in the server, there's like this like app class, which is like kind of like our internal state holder. And so he has, let's see, he has points, clusters, and a clusterer. So this clusterer works on the points in the clusters. We generate the points, clear out the clusters, and then ask our clusterer to do whatever. So the first thing that we're going to want to do here is probably support like either like an abstract type of some form here. There's kind of like 2 approaches, right? You could have like a tagged union. So you could say like union, or const clusterer in this language is a union of enums that's like enum tagged. You could say like agglomerative is a, how do you do this, like a agglomerative cluster. Or you could have like your divisive, and then you would have union. Here we go. Then here you would have divisive clusterer like this or something. Maybe this is an equal sign here. Union field missing name. God damn it. Zig union. I can't remember the syntax. Union enum. Here we go. It's not. It's this. Like this. Okay. You could do it this way. And this is probably what I would do in this case, because there's going to be like a small number of clustering algorithms. And this allows you to like inline stuff a little better, whatever. But since I'm also using this as an excuse to get a feel for the Zig language and stuff, the other option is you would have like a clustering interface, right? So in like your like C++, Rustland, whatever, you would have like, trait I clusterer or something, right? And this would have like a method that's like function cluster me, and you do like a step, whatever, right? In C style languages, you start doing like something a little bit more manual, right? There's a couple options. You do something like you have const I clusterer is a struct, and he's gonna have like a v table, so he's gonna have like a function or a field on this guy called like cluster me, and this is a function pointer, so he's gonna have to say like I am a pointer to a function, probably a const pointer to a function that does something, right? And then you assign these functions, and there's like a couple approaches to these as well. Sometimes in the Linux kernel, what they do a lot is they do something along the lines of struct like concrete clusterer, cluster, or I'm gonna do this in Zig syntax so that my language server doesn't like fucking bitch at me. And he's gonna have like my data over here, right? And he's like maybe like an int or something. Who fucking cares? And then he has like clusterer, which is an instantiation of the I clusterer interface. And what this allows them to do is it allows them to hand out pointers to this guy, and he doesn't have to hold any like external data here. Like this is like good enough. This cluster me as a const function. I have to say that it returns void or something for this to shut the fuck up. And so like in this cluster me function, you go like, well, how do I get a reference to like the data that I want to work with? And the trick that they use is they go like, well, I know that the interface I gave out is the second, is like 4 bytes offset into my struct. And so as long as I only ever pass around pointers to this guy and I don't copy him, then I can get like a reference to this data and I can work with him. The other thing that people will do is they'll store like a pointer here, which is like a void pointer, any opaque pointer, whatever the fuck you want to call it, depends on your language, whatever. And they pass in the pointer here. And then like the interface implementation of this guy has to like cast this back. So he would say like function cluster me takes in a pointer to any opaque, and he says like, you know, const self is equal to a pointer cast of pointer to concrete clusterer, and then you can access the thing through self. So since we're using this as an excuse to play with the language, probably this is the mechanism that I would use more often, because it allows you to copy around the interface without worrying about losing reference, like without invalidating references. But I do like kind of conceptually like the other method, where you say like, hey, we already have a pointer to the interface. Why the fuck would we store a pointer to the interface and a pointer to the thing that we're working with? I kind of like that conceptually. So I kind of want to try it. And I know Zig has this like field parent pointer thing, which like is like a built-in function that helps you like go from the address of clusterer here to the address of its parent. So I do want to try that. So we'll probably do it that way. Even though, so we're like 2 levels of I wouldn't actually do this away from what I would do naturally, right? I would naturally do this like union way. And then I would, if I were to do an interface, I would do it this way. But I want to try the field parent pointer way because it's fun and cool. Just for a little extra context, this container of macro in the kernel, this is where I like first saw this concept, and it's so fucked. Like, you see this macro, and it's just like, what the fuck does this do? It's like, what the fuck is this? But it turns out that like it's just get me the parent address. And so it's kind of nice that Zig has this field parent pointer like built-in compiler function. So I want to try it. Okay. So back to actual implementation. So we'll have a clusterer, right? And he, I guess, if we are storing this guy, he's going to have like a pointer. Can I put my font like 4 points? Yeah, I can get a little bigger. Actually, after all of that, I just realized this is going to be a disaster. Fuck. No, actually, no, this will still work. Never mind, we can make it work. Okay, const cluster is a struct. And he's going to have his like v table, so functions that we're going to have. What do we do on our existing cluster? We have next, which is just like step the algorithm once, and nothing else. Nothing else really matters. Okay. Hello, I saw you making a QR code decoder. I think running an edge detection tutorial will help you detecting which ones are black, which ones are white. You find edges with a stubble kernel along the edge. You can look for difference across the edges. Yeah, for sure, for sure. I was looking at that, and you still have to, when you do edge detection, you would still have to identify, which is like a dark, like which one is which. But you are right that that's like another approach there, and then I wouldn't have to do the like, clustering to figure out like which points are dark and which points are light. But I would still worry about sensor noise in that scenario, but I guess you could probably get away with like blurring stuff instead. But I'm gonna do it this way for now, even though I think you're right. Okay, so he's gonna have a next function, which is a function pointer that will take in, I guess, just clusters. So one of these guys, and he will return void for now, although later he might need to return if he's finished. We're just not really handling that right now. And then because there's this problem where we need to store the actual concrete type somewhere, and so I think what I'm going to do is I'm going to like heap allocate the actual clusterer, like the concrete instant implementation, and then I'll just say that this guy has a dinit function on him who is responsible for freeing the concrete implementation, which is like a little bit fucky for now, but that's okay. I'm okay with it. So this will take in nothing and return void, because again we are just doing this as a test. Okay, so now our agglomerative clusterer, he is going to store a vtable who is a clusterer. And so, which means that his clusterer is going to have to be instantiated in some way. So his next is going to be self next, or okay, right. So this guy, our agglomerative clusterer, is going to return. What's he going to return in this scenario? I guess a pointer to the clusterer interface. Yeah, and so now we are going to heap allocate the agglomerative clusterer, like we said. So we're going to say var concrete, or agglom clusterer, we'll call it. And this is what, alloc create. Do I have an allocator here? I do. Alloc create agglom this thing. And then we start assigning fields. So clusterer distances equal to distances. And now we have vtable we have to assign. And then we're going to return the address of clusterer vtable, I guess. And so now this guy needs to be assigned, like next is equal to clusterer, agglomerative clusterer next. Yeah, there it is. There it is. Okay, I think that all makes sense. And I guess we also need the free function. Okay, so now this next function, I guess he needs to take in the cluster interface pointer. So this is going to be a clusterer. And so that means our next function, wherever he was, needs to take in a... Oopsies. What the fuck? I just made a mistake somewhere. Clusterer here. Cluster and clusters. Clusterer. Yeah. Okay. which means this guy now takes in the clusterer interface, and he can go back to the concrete type. So we can say const or var const self is equal to field parent pointer. So we need to pass in the parent type, the name of the field, and the field pointer. Okay, so the parent type is agglomerative cluster. The field name is vtable, and the pointer to vtable is vtable. Expected 2 arguments, found 3. I see 3 arguments. Maybe this changed in Zig 012 and my language server hasn't been updated. Zig 012 documentation. Let's see. Field parent pointer. So before it would be this. Now it's this. It deduces the type by return. So here I go like this, and here I pass in agglomerative cluster. Interesting. And then everything else should just work. And then we need to implement our free function. So we will call this free, and he's going to take in a clusterer. He's going to go back to himself. And he is just also going to say self alloc destroy self, which means he kind of has to stash his allocator. Yep. So here we have alloc is equal to alloc. There we go. Cool. Cool. So when we construct our clusterer, we say try agglomerative cluster in it, and he returns a cluster thing. So we're chilling. Self clusterer. Okay, so now our interface struct, I guess, would have to store. So he has like a vtable inside of him, but we also want to be able to like call functions on him like it's normal. So we would want to call like a function next. Is going to take in self by pointer, as well as clusters by pointer. And he would want to return, he would want to say, like, I want to call my next function. Oh, this is weird. There's gonna be name collision here. So maybe we'll call this inside here. Maybe we say vtable is equal to is a struct, and that way we don't have to worry about name collision like this. So then we say self vtable next, pass in self and clusters like this. Which means that when we construct this guy over here, maybe we change this name a little bit, because now we have vtable double nested, which is annoying. So we'll call this interface, I guess. Inter cluster if, we will call it. I think that makes sense. So down here it's cluster if. Everywhere we wrote vtable before, it needs to be cluster if. Like this, like this. Yep. And then when we construct this guy, it's our cluster if dot vtable is equal to this. I think that's how it works. We'll see if we can build. So here we need to write try to make sure that our cluster actually checks if the allocation fails. Const function found, okay, expected type const function this thing, found const function that thing, app cluster. Oh, because he can return an error. So he's mad because this guy is could possibly return an error. So can we just say, hey, could you throw in any error on your thing here? I know that I should be using real error types, but I don't fucking want to. So, okay, 341. This guy doesn't like this for some reason, because clusterer should be clusterer, like this. Okay, and then we're close. Expected unit type found void on 364. So he is mad because this guy doesn't return an error. It's fine. 359 should be self-clusterer dinit. So function dinit on this cluster interface is going to return, he's going to call the free function. Like this. Okay. We're building. I wonder if we run. Seems possible. Refresh. Okay. Okay. Okay, so it's working. Surprising. Surprising. Okay, here's what we're gonna do next. Next, we're gonna make a dummy interface so that we can test the ability to switch between them at runtime. So what we're gonna do here is we're gonna call this dummy cluster, right? And we're gonna have a init function on him. Who's going to take in the points on the clusters, and he's going to return a clusterer. And what he's going to do is he's going to just make one cluster that has everything in them. So he's going to say clusters.add cluster. And then he's going to say add to cluster every single point. But except the points are point indexes, not the points themselves. So we have to say for 0 to points length, we have the point ID. When you're adding a point ID. We don't need an allocator here. We do need an allocator here. I lied. We do. And so we're going to say var clusterer. What did we say it called in the other one? Yeah, we did. Is equal to alloc try alloc dot create one of myself, and then we say clusterer dot cluster interface. We have to assign him dot vtable equals, and we make our little things. We say next is equal to self next or dummy cluster next, and free is equal to dummy cluster free. We have our free implementation needs to be pretty fucking similar to this free implementation, I guess. So this is just going to be a dummy cluster now, but everything else is the same. And our next function will just do nothing. And this guy can return an error, I guess. We'll just do nothing. Yeah. Okay. Okay, cool. So now we need some way to request from our application what our possible our possible clusterers are. I guess we'll just make an enum here. Clusterers. We have clusters, clusterer, and clusterers. So get fucked typos. And so this will just say we have a dummy option. And we have a... Dude. My fucking brain. Holy shit. Agglomerative. And in this language, can I, take enums and assign them to values? Clusters fuck? Clusterfuck? Yeah, clusters fuck. Clusterers fucks. Clusterers fuckers. Clusterers fucker. We can get all the combos. Zig language reference. Is there enums? Do I just enum literals? This is probably what I want. Can I assign them values in this language? Seems like I found my home. Dude, this guy's name is Clusters. That's so funny. What are the chances? Oh man, that's good. Can I not give them values? Can I cast an enum to an integer in this language? Maybe not. Oh, enum from int. Oh, okay. So, and then int cast. So I can go from enum to int with int cast, int to enum with enum from int, and then enum from int must be doing something like being a little intelligent. Like, I don't see anything in here that says I can do like equals 0. But if I said that I want like U8s here, then I can do this. It doesn't look like it's complaining. Okay. But I don't really care, I guess. Okay, so what do I want? I want to be able to take, so from the client, I'm going to ask the server, hey, what clusterers do you support? And I will return something that looks like an array of things that say basically ID, which is going to be whatever value here turns into. So it's like, I guess it doesn't matter because in JavaScript they're kind of like untyped. So we'll just say usizes. Like, who fucking cares? Or just number is probably more accurate. And then we will also give a name, which will be a string, right? I guess we are using JavaScript type names here, so this is going to be a string. And then when we come back and we say set clusterer, we'll just call like set clusterer with a query parameter of clusterer with the ID. And so really, in none of this do we actually care what the type of ID is. We just care that our int casts and enum casts will work correctly. So I think that we can just leave it like this, and we're just going to have to implement like a toString function. And I think probably it makes sense for that to be owned by the HTTP server, because like, does the app really care about how we stringize the clusterers? No. That's kind of like more like a UI thing, right? That's kind of just how are we going to present that to the user? And that seems like kind of like server decision. Okay. Fun topic. Something, something, something. K-means, oh, this is related. Okay, I was like trying to decide, looking at the link, if this is actually relevant. K-means cluster. From many years ago, that was written in shoes. Is shoes a programming language? What the lucky stuff. But that's kind of cool. Yeah, so you can see, we will get to something similar. Oh, so that's interesting. What are the sizes of the dots mean anything in your little fun thing from years ago? Or is that just for prettiness? It was very pretty. Yeah, just an approximation of z depth. So you were doing 3D, and then the colors were which cluster things were in. Pretty cool. Pretty cool. Okay, so here, somewhere, we are going to have to ask for which clusterers are available. So I guess we'll have one URI that you can go to get the clusters, and one that you can call to set the clusterer. And so we'll do something like clusterers is going to say, hey, this is a get clusterers, and that'll be have to be a perfect match. And then we'll have another one's like set clusterer, and this purpose is set clusterer, and he is going to be a non-perfect match because he's gonna have like a query param trailing on. Okay, and then whoever uses these guys is going to have to use these guys, you know. So here we're gonna have like get clusters. It's gonna have to do something. For now, we'll just say fuck off. Just so that we can stub this out and see if we can get compiling. Because I just wanna see set. Oh, this is set clusterer singular, of course. Okay, compiles. We're chilling. Okay, so get clusters. He's going to look at app clusterers, and he's gonna say, can I iterate enums in this language? Surely I can, right? Surely. That seems like the type of thing that like the like one place where Zig really shines is that I would guess that you could do that. So you're gonna say like how would I even want to do this? How would I want to do this? First of all, let's check if there's something already in the standard library for iterating enums. It seems like the kind of thing that might be there. Enum from int. Okay, let's check the standard library. It would probably be in their meta programming section. And they have field names that returns something, so that's close. Int to enum is in here. String to enum. Field info. Fields. Pub function fields, which would gives me Jesus. So if it's an enum, it gives me a list of enum fields. Hell yeah. Hell yeah. Dude, that's so fucking sick. Dude, because this is such a pain in C and C++. Because in C and C++, you have to do like, you have to put like a tag on your enum, like, you have to say like enum x is like value A, B, C, and then max. And then you have to iterate from 0 to x max, but then like you have all of your switches have to handle this max case, which is actually like a valid type for the enum. So that's kind of sick that you can just say, you can just iterate them with reflection. Pretty cool. Where was I was trying to do that? It's up here somewhere. So what? Function handle get clusterers. And I guess it's going to take in my request. Well, yeah, I was dealing with this enum case and recently in Go recently tuned how to sparse enum was awful. Oh yeah, that would fucking suck. You're just fucked, right? You just yeah, you're just fucked. Like without macros, I don't know how you would do it. Yeah, just screwed. Have to type generate it. What? Gross. I guess like you almost get to the point where you want to use like a like C++ generator where it takes in some like schema from somewhere else and just to generate like the setters and like the to and from serialized and deserialized because it's just like too fucked to type it twice. You like almost get there. I don't get there quite, but like I think about it and then I say no, I won't do it, but I want to. Okay, so it was stood meta fields for app clusterers. So this, I should be able to say for this field. And I should be able to just say here, stood debug print something. There's a common generator called stringer for making string names, which is used to make a map, but then they made the representation more compact and you can't use it to enumerate sparse sets anymore. So another generator, etc. Blech. Where I guess you're kind of saying a common generator, that's, I guess you're saying that that's some sort of like Go concept. Go generators. That is like probably like something that yields values or something. Anyways. Program args, got it. Oh, interesting. You can add Go generate program args, and then I guess the generate is like a program in Go, and then it generates things based off. Yeah, interesting. Crazy. That's wild. I thought, okay, so I've heard of people talk about Go as like, we love Go as a simple language, but that seems so far from simple language to me. Like, that's crazy. Okay, so for now, let's just call this function and print out this thing so that we can see what it looks like. Clusterers, and then try here. And so if I run this and then, oh, doesn't compile. Values of type enum field must be comp time no, but oh, because for loops in this language are runtime, but you can do something like inline for, which basically takes your for loop and unrolls it, and so that it can be run at compile time or something like that. Unused argument in any, right? So here I have to say dot, put a little struct wrapper on this guy. And then here I should be able to go to localhost 9999 / get clusterers. And now we fail. Whoa. HTTP connection closing. What the fuck? Oh, unknown MIME type for get clusters. Did I? Oh, it wasn't called get clusters. It was called clusters. Like this, maybe? There we go. Okay. So yeah, I do have 2 clusters where, and I don't even have to fucking stringize them. I don't even have to write the code to serialize because I can just take the enum name and shove it in there. That's fucking sick. Oh, hell yeah. So here I can just say, okay, so I'm gonna have like some like request, response, respond streaming, because I want to write some shit into the body. And so we take in the request and we take in the response streaming options. I don't know what those are right now. I can't remember. But it does look like we need to provide a buffer where we're going to temporarily write data before sending it into like through the TCP subsystem. And then, yeah, okay. This all looks like what I want to do. This all looks like what I want to do. So here, we're going to say, hey, here are our options. We're responding with some JSON. And now let's just write into our response. So we'll say for each of these fields, well, first we need to make a JSON writer. So we say var JSON writer is equal to JSON something. I think I have one of these somewhere else. JSON writer. Where do I make this guy? JSON stream is what they call it. So JSON stream. What the fuck? Why isn't it auto-completing that? Oh, because it's not how it's spelled? What the fuck? Equals JSON dot. Equals JSON dot. Write stream. Sorry. There we go. Write stream. And here I probably pass in my writer. So response. And the options are, I don't give a fuck. Okay, so now we say, hey, we are going to write an array. This probably has to be try, and then we have begin array like this. Probably, and then at the end of all this, we end our array. And then probably this, maybe I take this end by ampersand because it needs to be mutably written to. And then just for each of these guys, we say JSON writer dot write or begin object. Maybe it's not try. JSON writer begin object. Yep. And then we end the object. And then in here we say object field, and we'll say that first we are starting with ID, which just gets the field value. Yeah. And his name, maybe we put some spacing here. His name is just the name. Probably. And then at the end of this, we just say response.end. I think we're chilling. Let's see what happens. He doesn't compile, of course. Response has no members. Oh, so maybe we need to actually pull out the response writer here. There we go. That compiles. Refresh. Dude. That's so fucking sick. That's so sick. I'm so used to having to like make the enum string mappings, but just coming for free is so fucking cool. Hell yeah. Okay. So now on the client side, hold on, let's get a longer running version of the server. I'm Steve O. Thanks for the prime. Appreciate it. Come on, bud. Give us my environment. I just want to run. There we go. Zig, build, run, and here I say, hey, could you please use this, the live HTML stuff instead of the ones that are embedded in the binary? Then I can edit this on the fly, and I guess probably somewhere, I guess maybe this is like a whole new section where I'm going to have a button that's like change clusterer. Change clusterer. And he's going to have a label or an input that is of type not number, but I don't remember what it is, and it's going to be clusterer. I guess I don't even need a button. I can just do it when it changes. And what am I trying to Google here? Obviously not cluster. I'm trying to look for drop down input HTML. I can never fucking remember. Select. So it's not an input, it's a select. And my name, I have an ID and a name, so my ID is clusterer, I guess. Label for clusterer. And then I need some options. So option, and here I guess these options will get populated by JavaScript. Yeah. Okay. So I go to index.js. I'm a simple man. I see HTML. I follow. Oh, wow, man. Then I got lucky because often, probably most of the time, there isn't any HTML going on here. But I probably shouldn't tell you that because then you'll unfollow. It's always HTML. We're always HTMLing. Okay. So on load, we're going to ask the server for our clusters. So we're going to say, hey, could we get some clusterers? And I can, what's the syntax here? Await fetch, await JSON, yep. Clusterers, response, clusterers. Here we say clusterers. Of the countless hours I've watched your stream, I can't remember any HTML. We did a little bit on my TV show tracker. But yeah, it's rare. Although I would like to do, I do think that I should start using shitty HTML or HTTP servers as like my like in-process visualizers a little bit more often, rather than like spinning up an immediate mode GUI, because like the idea that it works from every language is pretty nice. Everybody always has a browser, and so I can just be like, when I'm doing like my quick and dirty thing, anything with a TCP server can serve a little HTML visualization, which is pretty cool conceptually. Okay, what was I doing? Trying to list my clusters. Okay, so refresh. Refresh. I have this clusterer guy showed up. I have an array of clusterers, solid. And so then I just say what? For clusterer, let clusterer of clusterers. We add to the dropdown something. So we need document get element by ID clusterers. Const clusterers select. And then certainly I need to add options. So I don't know if that's done by like creating HTML nodes of options, or if there's like, can I say, hey, this is a type of HTML select element? Hell yeah. And now hopefully this guy will tell me what I have as an option. Cluster select dot add. append child, add. Adds an element to the areas, blah, blah, blah. So, HTML select element. I just want like some actual docs here. Like, is there an example of using this? Add option 1. So here I create an option element. Yeah, okay, so they do need a proper HTML element. So var option, const option. In this language, does const mean I can't rename the variable, but I can mutate it? I think it does. So I think I'm supposed to use const here, which is gross, but you know, it is what it is. So create element option. And then our option dot value is equal to cluster name. This is text. And the option value is the cluster value. Yeah. And then we just add the option. Okay, so now if I refresh, it's fucked up. Clusterer select is null. Did I spell it wrong? For clusterer, ID clusterer. Oh, it's because it's not S here. Nice. Okay. Dummy agglomerative. Okay. So now I need to make it so that when I change the clusterer, which is probably like on change would be my guess. I should get out of the habit of just fucking guessing with JavaScript because like that's fucking dangerous. I think like JavaScript and C++ both are just like functions just don't do what you think they're gonna do. Like that's one of the reasons that I liked Rust so fucking much is like every time I guess it's like right. Where like in these languages it's just like who fucking knows what it's gonna do, right? It's not what you think. Okay. So here, do these like on change functions, they pass in the event? Okay, so I have the event here, and I can say console log event. Let's just like fucking see what that does, because I want to know what I get. So I get a change thing, and I guess if I want the value, I look at target.value or something. Undefined, so that's not it. Is trusted source element current target return value blah blah blah. Okay, so I guess current target's null, even though here it says it's not null. Am I fucking high? Source element. Oh, maybe this aside. This feels fucking weird. What is 0 and 1 here? Maybe I did this wrong. Well, I got the option text option name. Is there? How do I? Let's go back here and look for on change and look for a fucking change event. Fires when there's user selects an option. Okay. Oh, sick. Perfect example. Event target value. Okay, so I don't know why it was showing undefined in the browser, in the console. But if I say event target value, like undefined, yeah, so what the fuck? They are doing it with add event listener. That's a good point. I wonder if that does anything different. So here we're saying change. And then they are using a lambda, but I don't see why that should be any different. Does that really change it? No. It does feel like, can I like inspect element here? Value undefined does look wrong. So probably this is just wrong, which means we should look at what it is again. Console log clusterer. Like I'm just fucking up in some way. It's name and ID. That's why this is ID. Dude, what a fuck this. Oh, I'm gonna lose one. Oh. The fact that you can just be so fucking wrong and it's just okay with it is like, I don't know if I'll never get over it. That's so fucking frustrating. Okay. We get 2, 0. Okay, cool. So here we should be able to request that the server does something. So we say set clusterer. We're abusing gets, and I'm okay with it. So we'll just say ID, I guess. We'll just set the clusterer ID is equal to our value. Or just using JavaScript means you're never wrong. No, but I'm wrong all the fucking time. I'm wrong all the goddamn time. Do I have to like write async here? Yeah, it looks like I do. Never wrong, always buggy. I guess, yeah, it depends on if you think buggy is wrong. I think it's wrong, personally. But, okay. So you're saying, like, just do what you do, JavaScript, I'll fall apart at runtime. Like, I would prefer that, right? At least when you're writing Python, even though it's, like, fucking stupid that you don't get compile time errors, at least you get runtime errors. Like, I would kill for runtime errors in this environment. Like, it's so fucking stupid. But it's okay. I can't get mad. Like, well, I can't get mad, but it's just like, why? It's such a mistake, right? Like, just the one language we support in the browser is like this shit. Like, what the fuck? But you know, gotta do what you gotta do. I guess. Like, I just have to bite the bullet and use it because it's not fucking going anywhere ever. But Jesus. Just do Rust in the browser with WASM. I mean, you still have to go through JavaScript to get there, but yeah, I mean, that is like compelling. I would like to try doing some like, I don't know how painful the WASM system is. I feel like it's pretty painful. Unless somebody generates all the bindings for you. Okay, so here, I heard it's still pretty painful. Once WASM can have DOM and WebGPU directly, it'll be better. Yeah, I mean, that's really all I want, right? Is like, I don't want to have to go back through JavaScript glue. Because I think like the way it works right now is you have like, if I remember correctly, you have like this like WASM module, and he has like functions that he's allowed to call in the outside world, right? And so he has like, you know, if you want to like, you know, do something like fabs in C, you have a function here, like a dictionary here that goes to a JavaScript lambda that says like, if you wanted to, you would put like value in here, and then you would call like math.abs val or something, and then this gets like returned back into WASM through some glue again. And so I think like any like DOM manipulation that you want to do, you have to like write a JavaScript function in here that gets passed into the WASM module that he can use, and then probably somebody's already made a big list of these guys, right? Like, I know that Rust has the like web crate or something that has a bunch of these built in, but I think what's happening there is Rust, like the WASM, what is it called? WASM pack in Rust is like generating all these bindings for you. And so if you just want to like bang something out, it's like not simple. I don't like, yeah. But if I could just like, if the browser just injected those things for me and I didn't have to think about it, then that'd be great. Yeah, everyone who's done an integration has got one, but of course they're all different too. Fuck. I wonder what Ziggs is like. I would assume, based off everything that I've done in Zig so far, I would guess that they just don't do it. That would be my guess. But I could be wrong. Okay, what was I doing? I was calling set clusterer. Okay, so when this thing changes, my server should have set clusterer, and at the very least, let's print out the request that we got. So this is going to be request head target or something. I don't remember. We'll see if it compiles. Looks like it does. So we can refresh and change this to agglomerative, and we do get set clusterer ID 2. So now I can say, hey, I have this, like, I have some query parameters. So var it is my query param iterator, which I wrote off screen the other day, but he essentially just string splits at the question mark and ampersands. And I pass in my request head target. And then I just say, while it next gives me some param, query param, I can check its key. So if query param, if I guess I use stud mem equal, this is a U8 slice, and I'm looking for the key ID, and so if the query param key matches that, then I set my value. So I say ID is equal to null at first, probably. I think that makes sense. So this is gonna be like a usize. No, this is gonna be an enum. This is gonna be a cluster app clusterer. An app clusterers. Yes. Yes. He's gonna start as null. Then I'm gonna like try to find the query parameter for him. And then I will say ID is equal to enum from int stud format parse int query param value, because it's coming as a string. I think it's param maybe, I don't remember. And then here I need to try, and I need to say, hey, I want a, I don't know, a usize out of it, U8 out of it, I guess, and in base 10. And then I hope that this kind of works out. And then I can say var ID final or something is equal to ID, or else return error invalid ID or no ID or something, stud log error set clusterer called with no ID parameter. Okay, sure, like whatever, it doesn't matter. And then we call, I guess for now, let's just print this and we'll see what happens. Final, ID, final. Local variables never mutated, sure, const. Fine. Zig, I'll do what you want from me. No field name params and its value. Val. Sure. Still unhappy. What are we unhappy about? Probably I fucked up a stud debug print or log. Called referenced by. This is useless. I just need to comment out and see which one it is, I guess. Like this, maybe. Okay, that compiles. Uncomment this one. Still compiles, so it's this debug print down here. It's because I was trying to print this as a string. So this is a number. No? Still? Invalid format string for type. And for, oh, I need to write any here. It actually told me invalid format string for this. I just didn't fucking read it because I don't like reading. Okay. So now when I switch this to agglomerative, I do see agglomerative, and I set this to dummy, and I see dummy. Look at that. Isn't that kind of nice? That's kind of nice. Okay. Over here. We're back. Holy fuck, we've wasted an hour. We haven't done anything yet. Jeez. Set clusterer. So he's gonna take itself and a clusterer, and he's an instance of clusterers. And we are gonna switch clusterer. And if we get dummy, we are going to say our deinit the old clusterer and try setting a new one. And I guess probably we also have to reset the clusters themselves because the clusterers each kind of assume that they're in like a clean state. So we'll do this. And here, I guess before we do any of this, we can kind of do this in like common code. And then here, we will set this to dummy clusterer in it with these items. And, well, is it these items? Yes. And then here, we go back to whatever this guy was doing. And then we put a fix me on here because I don't want to fucking think about it. But on failure, we are just in a super fucking invalid state. And I just don't want to deal with that right now, right? Like if we get to like this point of the function and then this guy fails for whatever fucking reason, we're boned. Super fucking boned. But you know, who cares? Okay. So here we can start by setting the agglomerate cluster and then back to dummy. Oh, we didn't actually call the function, so that doesn't actually do anything. Let's actually fucking call the function. So we have self app set cluster with ID final. We still have to respond with empty. But now what we should see if this works is we should see that the sorry, one sec. I need to fix this compile error. I can't think and talk at the same time. Well, I can, but only if it's the exact same thing that I'm thinking. But we should expect to see that if we use the dummy clusterer, that all points just end up in the same cluster. All of them should be the same color. But if we don't, then we should go back to like the agglomerative cluster. And if we hit next with the dummy cluster, nothing should happen. Oopsies. What did I just do? Like this, like this, like this. Still compiling errors? Fuck off. 117. Fine. Fine. Oh, I just... expected 2 arguments, found 1. Add to cluster... Oh, so this is a const cluster ID here, and we add the point to the cluster, and make sure to get the arguments right in the right order, which we do. You know, neurotic me with strong type cluster ID and point ID, but I'm not going to do that because I don't want to. Here I have to write any error, I think, for this to compile okay. Otherwise, it will infer the error set, and it will be a different one than the vtable expects. Expected type const function pointer, blah, blah, blah. Found const function pointer. Oh, this guy has to take in the clusters as well. But we're just not doing anything with them, so it's fine. No field alloc, so the dummy cluster has to store the allocator so that he can destroy himself. Which is funny that it's the only field he's storing. That's okay. And still more. We didn't return. Wow, we really suck at coding sometimes. It sucks because of like the like incremental compilation. It's like super sick in some ways, but I don't like. I wish I could ask it to just compile everything. You know? Okay, so I go back to dummy. Nothing's fucking happening. Oh, but I'm also not refetching my data. So in index.js, after I request my new guy, I need to re-render. Like this. Like this. And now when I refresh, agglomerative dummy. Hey, there we go. Okay. So I think that's working. It's kind of nice. The only thing that I have to change here is I think on reset, it will always put it back to agglomerative. So I don't want that to happen. So I think here it's reset, re-roll point. So here, we kind of need to store which cluster we expect to be, I guess. So either the clusterer could have an interface, it's like, which one are you? Or we could just store clusterer ID or something. And you know, this is kind of or here's what we'll do. Here's what we'll do. We'll add a reset API. Yes. Yes. Oh, yes. I like that. And then we have on our thing, we can call function reset, who takes in clusterer and clusters. And he's just going to propagate to the underlying implementation. So return self vtable reset self clusters. And then on both of these guys, we need to implement our reset function. Like this. Boom, boom. And can we just do something crazy, like say self is dot d init, self distances d init, self alloc destroy. Ooh, this is tricksy. So right now our init function does like a heap allocation of the agglomerative cluster and like does all of this stuff inside and then returns pointer. We need to like do all of this stuff without resetting, without like reallocating. So I guess what we can do is we can just do all of this like instantiation stuff in our reset function and then just call that. So we kind of like take all this shit and put it down here. I guess maybe we take this stuff and this has to be done externally. So distances is like this. We kind of like set all of our member variables up. And then before we return, immediately call cluster if reset with points and clusters. We must need the points. I think that makes sense. And then here we ensure this total capacity. We need to take in points here. And does everything else just kind of work? It might. Yeah, sure. So I guess the only thing we have to do is before we do all this, we have to reset self distances, clear, and free. Yeah. Yeah. Yeah, sure. Fuck it. That seems about right. And then we have to give the same reset function to our dummy clusterer, but we just don't do anything. I guess technically we could reset the clusterer in the same way we did on initialization. That doesn't seem crazy. I think we do have to do this actually. We give this guy the same treatment where we say clusterer, cluster if, point, reset points clusters. And then the only thing we're missing is that our cluster interface has to take in points here as well. Yeah. Yeah. And now we can reset this guy without reallocating him. And maybe that's good enough. Let's see. So where were we? We were trying to, on the reset function, which is called something re-roll points or something. Here, instead of deinitializing this guy, we can just call reset with self points and self clusters. And probably this has to be try. There we go. Maybe that builds. Maybe it doesn't. Maybe she's born with it. There was this ad that always played. I don't know why I have this like makeup ad that I watched all the time when I was a kid. Maybe she's born with it. Maybelline. Why was I ever seeing this ad? Was this? Yeah, this is. That's been in my head since I was a child. But like, why? I would have been watching like cartoons. Very strange. But maybe she's born with it. You know? Where was I? I was looking for the reset functions. Reset is equal to Oh god, that ad. You know it. It's in your head too. It's stuck in there. It's infected everyone. We all have it. All right. I guess that just means it was really fucking effective, hey? Like if I'm still thinking about it 25 years later, they just did a good job. But why? Why do I care? Self points expected at point. This has to be items. 420 items. Boom. Are we there yet? Oh my god! There's so many bugs. I keep fucking up. This is why. Okay, but. This is why I lose my fucking mind when I'm writing JavaScript. Because all of those, every single one of those bugs would have just like manifested in some fucking weird way, and I would have been so fucking angry. Okay, so if I go to like the dummy cluster, he's crashing because I did something wrong. So in 78, I free on this guy, and he's probably mad about like a double free because I probably freed him by mistake somewhere else. Maybe. Distances. Oh, clear and free. Oh, no, but he should immediately reset himself. Oh, here. What the fuck is this? Why is that there? It shouldn't be there. Bug. Refresh. Okay. Reset. Good. Agglomerative. Reset. Dummy. Reset. Okay, I think we're chilling. So agglomerative, I run like, and I say, go 99 steps. He'll go to the point where it's all blue, and I hit reset, and then reset again. Cool. Looks like it's working. Okay, so Jesus Christ. 1 hour, 16 minutes, and 50 seconds into stream, and we've finally done the part of the work that is nothing. The part of the work that is something is that we wanted to implement the divisive clustering. So let's take a look at this. Divisive clustering. So last stream we looked at this guy who's basically saying, when we're clustering, take the closest two guys and stick them together, and just do that over and over again, and eventually you end up with some clusters. And you have to like decide when to end by like saying like, well, either like we've looked at enough points, or like the points are too far apart from each other. But there's no real end condition other than the friends we made along the way. But this guy is kind of like the opposite. This guy's saying, we'll start with one big ass cluster, and we'll try to find the guys in this cluster that are like far away from everyone else, and like start splitting them out. So I've been Googling mathematics notation because I'm so fucking lost. But I think I get this now. I think I get it. So you start with one big cluster. They call it C0, and he has all your points, 1 to n, where n is number of points. And then you say this other thing, dude, fuck math people, dude. Look at this shit. You make a thing C with a little bit, like a very, very, very slightly different top right corner, and he's a completely different concept than C without that, like with the full top right corner. Like, look at this shit. Look at can we just look? Let me paste the picture. Let me paste the picture. Copy, paste. Look at you think I'm supposed to be able to fucking tell the difference between that and that? The difference is like what? Like 4 pixels, right? It's like there. That's the fucking difference? Are you fucking kidding me? Anyways, so this C without the top of the hat is your clusters. C with the top of the hat is an individual cluster. So you start with fuck math people want to subscribe, JKL if you want to. Yeah, I mean, like, I just feel like the math is so, like, you would think that people who are so, like, engaged with rigorous proof would want to prevent mistakes caused by stuff like this. Like, I can't imagine that people don't make mistakes from this unless they just like have more state in their head that they're like keeping in like really good spots, but I can't imagine. I can't imagine. Anyways, so they have a bunch of clusters. They start with one cluster that is all elements. Here they iterate the following until this is equal to n. So I think that if I understand correctly, on sets, the pipes around the set mean number of elements. So they're saying like keep going until you basically have one element per set. Find the current cluster with two or more objects that has large diameter. So here I think they said somewhere else that this is this a delta? Lowercase delta. No. Oh, yeah. The triangle is the big delta. The funny squiggle is the lowercase delta. So they're saying this delta function is like a metrics of distance between 2 points. So they're saying for each set in the set, so each set in your list of sets, find the biggest one according to the criteria of which set has the biggest distance between 2 points, I think is what this is saying. So you have this distance function that takes in 2 points. For each set of 2 points in your cluster, you take the maximum of those. So you iterate over every combination of points and find the biggest distance. And then you take the argmax of that, which is like the index of the index of the set that has the biggest distance between 2 points. That's what this says. Then we find the object in this cluster with the most dissimilarity to the rest of the cluster. So this is saying for each point in your set that you're now like has the biggest difference in it, take the average of its distance to every other distance, right? So this is distance function between I and j. You're using I is every point in the cluster. You're iterating over every point in the cluster. That's I. And then you're iterating over every point in the cluster again, except you don't consume I. So for this is just sum of the distance between every 2 points divided by however many things you did. Yeah. So you take the index of the point that has the largest average error to all other points, average distance. Take that point out, make a new set where that is the only element, and then you now have to like migrate points from your old set that you were looking at to the new set. And the way that they migrate is they define this function d, where d is if we look at the math notation here, we can figure it out. So C star is the set that you're pulling things from. C new is the set you're putting things into. Both of these look kind of like averages, right? So this is sum of all distances in the new set divided by the length of C new. So this is just average distance in the new set, and this is average distance in the old set. And so as you pop points out, they're kind of saying what di, so you take the maximum of this function, so you go over every point in C where this C doesn't have an under thing in it, so that's not really clear, but I assume that this is for, hold on, so as long as C isn't empty, keep migrating objects from C star and add them to C new. To choose which objects to migrate, don't consider dissimilar to C star, but also adjust for dissimilar to the splinter group. So you're probably iterating over potential points to remove. So you take, for every possible element that you might want to move from the old set to the new set, you run this function, which is like average distance from this point to points in the old set minus average distance from this point to points in the new set. And if that's bigger than 0, then we move it. And if it's not bigger than 0, then we don't move it. And they're saying stop iterating when di is greater than 0. But I think that you probably don't have to iterate here. Maybe you do. Maybe you could do this in one shot where you take all of the elements where oh no, because your averages inside are going to change as the sets change. So you have to do this over and over and over again. Okay. So intuitively, DI measures how strongly the object wants to leave the current cluster. Yeah, right. Average distance in the new cluster versus the old cluster. So like in reality, that's not too complicated. I struggle a lot more when I'm trying to like decipher the math notation than when I actually think of the algorithm. But it's like pretty straightforward. It's like take average distance to things. Average distance is like a common theme in here. And then you say which one has big average distance, move away, find things that have close average distance, move in. And then eventually stop moving and then go again. Right? That seems not too bad. Not too bad, not too bad, not too bad. Not too bad. So we will make a new clusterer. Our new clusterer is Diana clusterer. Because I think they said that this is Diana, which is, I think, like, the basic principle was published as the Diana algorithm. Dude, I love the every algorithm has to have a catchy name, right? Like, this is such a stretch for saying, like, split shit up. You're like, Diana, we're gonna name her. Anyways, so we're gonna make a Diana cluster. And he's gonna have a cluster interface, which is a clusterer. I think that's the interface name, yeah. And he's also gonna have to have a list of sets. But the list of sets is managed externally. So I wonder if we have to hold anything. Maybe we don't. Maybe we'll just start running our next function and we just kind of see what happens. So our next function is going to take in the cluster interface as clusterers. No, clusterer. Yes. Man, I should have picked better names. And he is actually going to have the exact same API as everyone else, so we'll just copy paste. In fact, we'll just have to copy paste all of these guys because he has to implement all of them. But we won't take the implementation right now. Although the free function is going to look pretty much the fucking same, so let's start there. So he's gonna have to store an allocator because he heap allocated himself and he's gonna have to let it go. And let's start here. So our next function, we are iterating point by point, right? So in here we're using both the clusters and the points because we're using this distance function. So let's start by making our distance function. So we'll take in A, which is a const point, and B, which is a const point. I guess really that's not really maybe that should be part of like the point API. Or fuck it. We'll do it here. That seems fine. B is a const point, and this is gonna have to return like some distance. And I guess for now we'll just do Euclidean distance squared. So ax minus bx is this. Y distance is ay minus by. And then we do return x dist times x dist plus y dist times y dist. And you could square root this because Pythagoras, x squared plus y squared equal, or a squared plus b squared equals c squared. But why bother square rooting it if we're only comparing what's it called? Like we're only comparing distances to each other. So if the square distance is going to be in the same order as the non-square distance, so there's no point in square rooting. Okay, so let's, I guess on init, we're gonna do something like set our clusters. We're actually gonna do the same thing that the dummy cluster did, just like by chance. We are going to, well, first let's replace these guys with Diana cluster, not dummy cluster. We are going to create our cluster, which is a Diana cluster. He is going to reset himself, return the cluster, and his reset function is going to look the fucking same. So he's going to start by basically assigning every point into the same cluster. Points, clusters. Yeah. Yeah, okay, so he starts there. Every point goes into the same cluster. So that's number one. Now we're on iterate the following. So here we say, this is our cluster interface. This is the clusters. And we're gonna say const self is equal to field parent pointer. So here we have to say that we are a Diana clusterer, and we have cluster if, cluster if. Boom. Okay. Actually, do we use self at all? We actually might not. We might work only with. We have like no internal state to manage. I don't think. I guess technically we could cache the distances between points so we don't have to fucking calculate them over and over again. Right? Like what we're going to see a lot of here is distance calculations between the same two sets of points. Maybe not. I'm okay with lazily calculating them from now. And then if we decide that that's taking a long time, we could try caching it, but I don't see any reason. It might be fine. It might be like the memory cost of storing them is like higher than the CPU cost of just recalculating. Because like the recalculation isn't that complicated, right? Like this is pretty straightforward. Let's see. So here, find the cluster with two or more objects that has the largest diameter. So we're gonna go through each cluster. For clusters, and we have this like cluster iterator. So this is clusters, cluster IT. And this guy, what does he give out? He just probably gives out like slices. Yeah. Maybe he should give out his cluster ID as well. But for now, we'll just say, for now, we will just say, while true, we'll just keep track of it externally. So we'll say var cluster ID is equal to 0. And then we'll say, while cluster IT next, we have a cluster. And here we'll say defer cluster ID plus equals 1. And so here we say for each cluster, find the maximum distance between each point, the points in that cluster. So we have cluster. What is this thing? Is a slice of view size? Right. So now we actually have to look at the points, which we haven't actually needed to do in other algorithms. So the API isn't here, but we just have to adjust all of these guys now to take in the points as well. Like this. And here he also has to take in point like this, and then down here, or up here maybe? Here we need to say, please pass us our points and use them here. And the reason we don't just stash them is because fuck self-referential structs. You know? They just piss me off. So we just pass the same thing in every time we call next. Yeah, this. Boom, boom, boom. Dum, 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 dum. Okay. Chilling, I think? Okay. So now we have access to our points. I'm actually not sure if we need ourselves here, so we'll just put that away for now. And we'll say function find maybe yeah, we'll just say max distance between points. Yeah. And we'll take in a cluster. So point IDs we'll call it. And the points. Yeah. And this will return F32. And so here we can say max distance between points. We take in the cluster as the point IDs, and then the points as the points. And so what is this guy saying again? He's saying, hey, find the index of the cluster that has the maximum of these guys. So here we'll say var max cluster ID is equal to 0. And var max cluster distance And I guess we start by taking the first, we do this calculation once outside the loop. Or we do it inside the loop and do while true like this. No, I think it's fine. I think it's fine. No, yeah, because we want to store the maximums outside. So we say cluster it next, or else stood debug panic with a message that says clusters not initialized for Diana cluster. This is a bug from the perspective. Like, this should never fucking happen, because we should always have at least one cluster, or else somebody fuck with our shit. Don't touch it, you know? Okay. So I guess this is, we should actually call this const first cluster is equal to this. And then we start with the max cluster distance as the first cluster fed into max distance between points with max or first cluster and points. There we go. Okay, so this guy, finding the max distance between points, this should be easy. We should just be able to say for point IDs, we have a point ID, right? Then we loop over every single point. Ooh. This is not quite right. We need the point that we care about here. Oh no, yeah, we loop point IDs again. Yeah. Here we go. We double loop point IDs, and we say this is A and this is B, and if A is equal to B, continue. We don't care about this one. Otherwise, we say distance 2 of points A and points B. So here we start with max is equal to 0. And then we say max is equal to max of max and this. Chillin'. And then we return max. Boom. Boom. Easy. Okay. So now we have the maximum distance between points. I guess, like, this is one of those times where we're building things up where it's like we should unit test this before, if we see a bug, like, you know, this is a potential source of error. We could have fucked that up in some way. Okay. So now, test one of those. Yeah, dude, for real. But like, you know, they're kind of useful sometimes. So here we say max cluster. So here we say cluster max is equal to this. And if the cluster max is greater than the max cluster distance, which is confusing naming, but shut the fuck up. Max cluster ID is equal to cluster ID, and max cluster distance is equal to cluster max. I'll call it cluster distance. Fine, don't shut the fuck up. You were right. Okay. So now, after this, we should have the cluster that we want to start removing elements from. This is C star. We have C star now. Now we find the object in the cluster with the most dissimilarity to the rest of the cluster. So surely we have right? Surely we don't have to loop again to figure that out, right? Like, that's known. So let's say this max distance between points. He should just return which points as well. Max distance is equal to some struct, which returns A, B, and distance. Do. This could easily go from cluster distance to cluster fuck. Definitely. So this guy's gonna return a max distance. Oh no, wait, hold on. This isn't. I take this back. this is actually trying to find the object with the most dissimilarity. So for each item in here, oh, we are still doing a double loop once though, so we must be able to extract this information. So let's go back here and we'll say max distance is going to return a struct that has a worst point as well as a max distance. And then the question is, do we believe that calculating this once now is actually better? Because now we're actually going to be doing 2 floating point operations per loop, when for the vast majority of them we don't actually need to. So maybe looping again is actually better, because we'll be doing less floating point operations per loop. I don't really know in my head whether it's better to loop twice and do a floating operation once, or if it's better to loop once and do 2 floating point operations that you're going to discard some of. I have no fucking idea. It depends on if like the thing stays in cache, and if you're limited more by like your floating point unit being slow versus like memory, you know, who fucking knows? So I'm just gonna loop again because I don't want to think about it. I hate thinking. What do we do here? I'm new to this stream. It's a good question. What the fuck do we do here? Right now we're working on a QR code scanner, and as a part of that, we are looking at like different clustering algorithms. So we have this like little UI that we've built up where we can like drop points in here and run some thing by some number of iterations. He's not running right now, so I'm not going to demo him. But that's kind of like in this realm where we're trying to go from something like this, where we can like take an idealized QR code and we want to turn it into something that works on something like this, where you have like this like grainy unreal thing. And so we're looking at like, well, how do we go from like samples in real world points to like, you know, yes and no, you know, groups of points, figure them out. Higher level, what the fuck do we do here? It's kind of whatever the fuck I feel like, which trends towards reinventing things at like low level with the intent of trying to understand them at a higher level. So if you check out the YouTube, there's like operating systems in Rust, like, oh, what's in there? Jeez, my brain's melting. Operating systems, 3D game engine, diff tool with a diff algorithm, visualizer, like virtual file system, like neural network. There's like lots of, you know, whatever the fuck we feel like, which trends towards, yeah, less, often like closer to what you would be doing in like C++ Rust land than what you would be doing in, you know, there's no fucking way you're ever going to see me on stream touch React, right? Like let's just put it that way. Okay. What were we doing? I got distracted. We were trying to work on our cluster algorithm. So, right. We were on step 2 here. We need to find the item that is most dissimilar. Right. So, we take each element in 4 clusters. Do I have like a way to extract like a specific cluster? I guess here, instead of storing the max cluster ID, we just store the max cluster. Yeah. So here we'll just store the cluster itself, so I don't have to work with like indexing. Fuck this cluster ID. And then we'll just say max cluster is equal to the cluster. And I think that assigning slices in this language, I think that that's just a pointer assignment, not a copy of the slice. I'm pretty fucking sure. Because it couldn't. It doesn't know the size limit. It's not going to heap allocate on the hood for us. So yeah, it's just a pointer assignment, which is what we want. And then we can just say, so for max cluster. I code React for a living, and I wouldn't suggest anyone touch it with like a 10-foot pole. I mean, there's so much, like I understand why it exists, right? Like I get from the perspective of someone who you're in the browser, right? And you're just like, I just want to make something. And you don't want to fucking understand the like 9 layers of hell below you, right? How many layers of hell are there? How many layers of hell does Dante have? 9, yeah. You don't want to understand like the 9 levels of hell below you, right? You just like, I want to like make a thing. And so like I get the idea of like, it's the same as like working with like a game engine, right? You're like, I don't want to understand how to like render a 3D object. I just want to take a 3D object and move it around. And it's like, I kind of get it, but like the whole idea just seems so backwards to me. Like tying yourself to a JavaScript framework sounds like you're just asking for pain. And then like that JavaScript framework is doing so fucking much for you. How are you ever supposed to understand what the fuck is happening? Right? Like I'm sitting here being like, well, how does printf work? Well, I guess like it goes into the kernel and we have to like look at the kernel driver implementation for a TTY, and then there's like a TTY over here and a PTY over here, and they talk to each other because we're simulating talking to like a terminal emulator from the 70s that actually had a physical connection. And it's like, I'm like struggling with like, what the fuck does printf do? I can't imagine being like, what the fuck does like React do, right? It's just like it's so far removed that I just would never get it. And then the idea of like frameworks instead of libraries, also it's like I would never want my dependency to like dictate my life, right? Like when I like pull in a dependency in like the ideal world, I wrap the dependency with my own wrapper and then never expose the dependency other than like this like one place where I'm using it. And then everybody else, that way you can like switch it out later. Like if you're like trying to like use React and switch to something else, what the fuck are you supposed to do? You just spend like a year rewriting your application? Like what the fuck? But I get it. There's reasons that it's good, but I wouldn't touch it. Just because of my ideologies and whatever. Okay, max cluster. So for each element in our cluster, we're gonna look at some point ID. And what are we trying to figure out? We're trying to figure out worst point. And I guess we'll just start them out as like an I size or something. U size. And we'll start them out as a stud math max int for U size. Just start them somewhere completely like fucking obscene. And his worst point value is going to start at 0. Average distance is going to be an F32 and we'll start him at 0. Okay. So then we can iterate point IDs. Did you just touch either with 10-foot poles? Yeah, I guess I kind of did by talking about them. So for each one of these, we are going to iterate the cluster again. So we have point ID again. And here, what are we gonna do? We're gonna iterate every point and check its dissimilarity. So we'll call this A and B, or point ID and B. Other point ID, I guess. So if point ID is equal to other point ID, fuck off. Right? We don't give a shit. And otherwise, we create a sum. So we say distance sum, or a sum total is equal to 0. This is a float. And here we say distance 2 between points point ID and points other point ID. Okay, we're getting somewhere. So we say sum total is plus equal to this. At the end, sum total, average distance is the sum total divided by the number of points. So this is max cluster length minus 1. Yep. So that's the worst. Now we found this guy, and now, oh, we haven't found him yet. So we have to say if average distance is greater than worst point average distance, worst point average distance is the average distance, and the worst point is the point. So now we've found our candidate for removal. So we say move from, ooh, well, fuck me. So our clusters are stored in like heap allocated vectors. So we have like cluster A is like 1, 2, 3 points 1, 2, 3, and 4. Cluster B is 5, 6, 7, and 8. And so if we now want to say that we want to move a point from one cluster to another, we like pop this and push it here. But now all of a sudden this like storing of slices no longer is reasonable. We have to work with cluster IDs and we have to pull them out every single time because like they might move around. Right, because if we pull like if we have like a pointer to this guy, this is like you know, he's just kind of like pointing drawing an ASCII sucks ass. But you know, he's kind of like pointing up here like this, and then when we reallocate this guy, he might just like end up like, you know, somewhere else. And then all of a sudden like we're pointing at invalid memory. So we have to store we all earlier when I was like fuck storing the cluster ID, I was wrong. So max cluster ID is equals 0. And this is first cluster. This is first cluster. Max cluster. We have cluster var cluster ID is equals 0. And then here we say defer cluster ID plus equals 1. Here we say max cluster ID is equal to cluster ID. And then here we need to I don't know if we have like a function to like pull a specific cluster from our clusters. Get cluster, we do. So here we just say for clusters, get cluster, max cluster ID. Okay. So var max cluster. I guess we just type it again here. Not the end of the world. And maybe we God. Const max cluster is equal to clusters get cluster max cluster ID. This maybe has to be var. We'll call it const for now. Okay, now we're chilling, and we just have to be careful about we have to reassign max cluster sometimes. So we can't do any modification of the cluster from within the loop. But I don't think we have to. So here, did we do everything we need to do to get the worst point? We iterate this, we get the average distance. If the average distance is worse, then okay, cool. Cool. So we found the worst point in the cluster. So now we can do something like clusters move point. Yeah, so we're gonna say the point ID. Yeah. We need a new function. We need a new function on our abstraction. We love abstraction. Okay. So here we have a way to like add to a cluster. So I guess maybe what makes sense is we'll just have like a remove from cluster function. Oh, we have add to cluster. We'll say pub function remove from cluster, and we'll say we have some clusters and we have some point ID and we have some cluster ID. Which is kind of confusing in terms of like order of operations here, because here we've kind of like reversed this, right? We've said before we had cluster ID first, then point ID second, but that's because we're saying like add this point to this cluster, remove, fine, we'll do it in the same order. I was gonna say that makes sense, but it doesn't make sense. It doesn't fucking make sense. We'll do it in the same order. And so first we say, what is the index of the point in that cluster? We'll say what? We have like point ID index. Gross. So I guess we have like our cluster is this. We say we go through each of our clusters. We find the cluster ID. We say the point ID index is stud mem index of. Does index of assume nonlinear? Because there's index of linear. Use Boyer's Moore Horsepool. Dude, can you imagine if your name was Horsepool? That would fucking suck. And your friends just have like normal names like Moore, and they're just making fun of you all day. And you can't be taken seriously on your paper. But I don't like. Is this does this assume sorting? Is what I actually wanted to do. No. So index of 1, 2, 3, 4. So these aren't sorted. Yeah, it's not sorted. Oh, but this is like using another slice. I don't need to use another slice. I can use something scalar. Index of scalar. Yeah. What is index of scalar pause? He takes in a start index. Okay, so we can just say index of scalar. And we have our things are usizes. And we're trying to look at the cluster, and we're looking for the point ID. Yeah, yep. And we will say or else here and panic. Because point ID was not in cluster. Because, like, you know, anybody calling this, fuck you if you're not using a point that's already in the cluster. And by fuck you, I mean fuck me in 5 minutes when I make a mistake. And instead of, you know, being charitable to myself, I'll say fuck you. I hate you, future Mick. So I guess we'll just do a swap and pop because there's no ordering of points in the clusters that needs to matter. So we'll just say so this has to be cluster items here, I think. And I think we're chilling. Okay, so cluster. Let's think about this. So is there like a swap thing on here? Cluster. Why is my autocomplete doing nothing here? Does it not know the type? It thinks it's a usize pointer? Whoa. That's not right at all. Clusters is a bunch of array lists unmanaged. So this should be, a cluster should be stood array list unmanaged usize pointer, right? This should be this. Am I high? Self clusters, items, cluster ID, yeah. So I don't know. I don't know why it's not working. Yeah, it's just, I want some fucking, oh, maybe I'll fix that R. Okay, there we go. So is there like a swap in here? Swap remove. Oh, hell yeah. Hell yeah. Okay. So this probably can't fail. So we're chilling there. And we can go back. And we can just say, max cluster, it's clusters. Remove from cluster, and we remove this from max cluster ID, and we remove the worst point. And then, do we not, we need to put it somewhere. How do we know where to put it? Oh, we put it into a new group, of course. Clusters, add cluster. So here we say, var new cluster is equal to clusters add cluster. New cluster ID. And this is a failable thing. And then we say, clusters add to cluster. And there's some order of operations here. Right? Which guy comes first? Cluster ID. So we add to the new cluster ID the worst point. Okay. Okay. So then what do we do? Then we have to iterate all of the points from the collection that we just removed this from. Which is kind of interesting to me. I would kind of assume that you would look at other points as well. But I guess when you're dividing, you already stopped. So you already know that you only care about the subset of items in your current pool, I guess. Okay. Okay. All right. So now we calculate. Oh god. As long as C star isn't empty, keep migrating from C star to C new. Okay, that makes sense to me. To choose which objects to migrate, don't just consider dissimilar to C star, but also just for dissimilar to the splinter group. Let I star is equal to. Dude, like, come on, man. Use a different letter, right? We already have I star right here. Why are we this is just a different thing. Oh, math people. Okay, so this is a new thing. I star, new I star. So we're looking for the next candidate to remove. So they're saying I star is like the thing to remove. And we're just looking for the next thing to remove where I star is defined as I. So this thing that was I star is now I down here. I think. So for each I in, no, this is each candidate point for the next one to remove. So for each item in the collection that we just, for the collection we just popped from, run this function, and we check its similarity to each, we average its distance from the old thing to the new thing. Okay. Which kind of, we already have that. We have max distance between points. But maybe we want one that's like average distance between points, because we're going to use that again. So we'll do this. Average distance between points. And that's just going to be kind of like this loop here. Almost. It's kind of more of this. Average distance between points. So we're going to have a point ID, which is a usize. We'll have other point IDs, which is, or yeah, we'll just call it point IDs. Point IDs, and points. Where point ID is the point we're looking at. Point IDs is the points in the set. And points is points. Okay. So that's kind of like, we're looking at like this loop here. Like this. And we're going to say for point IDs, here we go. We sum these things. Then we, I guess what we'll call this is total distance between points. Sum distance between points. Yeah, let's do this. We'll return the sum. And the reason to do that is because the divisor on these guys is kind of different depending on if we need to subtract one or not, which is kind of like confusing. Oh no, here's what we'll do. I've got it. What we can do is we can say in this case, offset plus equals 1. And then here we divide by point IDs len minus offset. Yeah. Oh, baby. Okay. There was actually a bug in there also in this version. This -1 was supposed to be in brackets, but it doesn't matter now because we accidentally fixed it, so. Okay. So here, wherever the fuck we were doing all that before, here we're going to say const average distance is the average distance between points. Here we take in the point ID, and we take in the max cluster points. And was there another argument? And the points. And then this stuff kind of goes away. Okay, and now we can do this same thing. So we can say here that we have like some loop that we're doing. Where until we've run out of things to migrate. As we iterate this guy, we have to refetch the clusters that we're working with. So we'll say const new cluster is equal to clusters get cluster new cluster ID, because these guys have been like modified between loops, and so if we have to refetch them every time, or else it's invalid. So we'll say old cluster here is going to be max cluster ID. Okay. Now we are going to take new cluster. We're going to loop over all points in the new cluster, old cluster. And we're going to look for each point, and we're going to say, I guess we kind of have like worst point again. Right? This is kind of like just this. Like this is very, very similar to this. Very similar. Here's what we're going to do. I'm just going to put this in a scope so I don't have to worry about fucking up. Oh, actually, no, here's what we'll do. Okay, worst point, is this used anymore? I think no. So I think that we can just reuse this, which is awful, but it's okay. I don't think we keep the worst point average distance now. We're keeping the point that has the highest desired move. Worst, so maybe we'll call this var, like, what do we want to call it? I don't want to say like the largest candidate, but we'll call it the best candidate. And we'll call this the best candidate score, we'll call it. Sure, that seems fine. So here, his score, I guess this comes down here. Yeah. Yes. So for the old cluster, we go through all the points. And we say, hey, average distance between points for the point ID and the new cluster and the old cluster. So, and we subtract new from old. So we'll call this const score. And yeah, surely this should be broken into 2 lines. Yeah, yes. And here we'll say that if the score is greater than the best candidate score, and this can be below 0. So this actually has to be like a stud math float min. And does this give me, like, is this going to give me a really big negative number? Or is this going to give me a really small big number? Really small big number. So I guess I don't want small number. I want biggest negative number. So can I do negative float max? Is that valid? I don't know if negative float max is allowed. I guess we'll find out. Because if I don't know if like the negative and positive exponent maximum like match up to each other. Float IEEE. I guess I think that there might be a bit for if it's negative or not. Yeah, okay. Sign bit is hard coded in there, which kind of indicates that the negative and positive maximum value are the same. Does kind of indicate that. Okay, so if my score is better than the best candidate score, I say best candidate is equal to point ID. And the best candidate score is equal to the score. And then after all that, we just move the thing from the old max cluster ID. We remove the point. So best candidate. Best candidate. Candidate. Got a little extra I in there. Candidate. ATE. There you go. So we remove the thing from the cluster, and then we add clusters, add to cluster. We add this to the new cluster ID. And here, if best candidate score is less than 0, we break. Maybe. Maybe it's good. Like, theoretically, that could work. Maybe. So now we just need to actually support instantiating this cluster. So we'll call it Diana. And then here we have to say if we get Diana, we need to create the Diana cluster. And certainly instead of anything sane happening, we're just going to like not compile and then crash later. Unused function parameter at 219, I think it said. Yep. At 66, he's not happy, probably because this guy. What's he complaining about? 150 compilation errors and waiting 30 seconds for the first successful run. Yep, as always. So he's expecting. Oh, the vtable wasn't updated to take in the points. Vtable here. He needs to take in a little const point here. Okay, max cluster ID is comp time int, and he needs to be actually more like a usize, not a comp time int. It's going to complain again because panic takes in 2 arguments. What are we building? We're building some clustering algorithm visualizations so that we can work on signal processing for a QR code reader and have better intuition about what approaches work for our data points. What language? Zig right now. This is a usize as well. Max is also a usize probably. No, Max is a float 32. Here. What else? Add to cluster errors ignored. So just a little slap try on there. Points here are not happy because 196. What is it complaining about? Max is the max distance between points A and points B. Oh, here I probably have to put little ampersands on these guys. Okay. Yup. Offset 0 at 206. So he wants usize probably. And then at 171, we have some float conversions to do. So these guys have to be ints to floats. Like this. Oops. Like this. Womp, womp, womp. Float from int. Debug panic at 467 is unhappy because he needs to say, hey, we have no arguments. We don't give a shit. Expected const at point found at point. So another distance squared failure at 213. So this guy has little slap some ampersands on there. Sum total between float 32 and usize. So another float from int bad boy. Like this. And then swap remove were ignored, but we don't really care about that. Right? This is like remove. What does it return? He just must return the type that the value we removed. We don't give a fuck. We don't give a fuck. All right, we compiled. Let's see how fucked this is. Okay, so Diana, we start here. Everything is one color. And let's try to do one step and just see what happens. No fucking way! No way. It's doing something. I'm not really convinced that it's right. Let's re-roll a couple times. Let's like reduce the cluster radius and start with 2 clusters, right? So 1 step here. Yeah, something's wrong here. Let's inspect. Or not inspect, network. Okay, we will reset a couple times. And hit step once. That fucking looks like it did what I wanted to do, to be honest. So here we got back 2 clusters, and they are split. So it could have been that the colors were a little broken before. We might just got unlucky with the cluster with the number of clusters. So let's do 4 clusters now. And on each iteration, I think that we're supposed to be bringing out 1 more cluster. So here we split the clusters in half, and then here we should bring in a 3rd cluster, which we did. And then here we should hit 1 more cluster. Okay, so this is fucked up, right? Unless okay, so we have 1, 2, 3, 4 clusters, which is what we're seeing here. One. So we're getting unlucky with colors, maybe if we refresh a few times. Okay, 1, 2, 3, 4 clusters. So the fact that this guy's the one who got split out is a bit of a problem, I think. I think also. Hold on. I think that probably the cluster color picker is doing something fucking stupid. That's my guess right now. Let's look at how he's supposed to work. So what we're doing right now is we're caching some clusters. So we generate like a set of colors that are kind of like as far away apart as they can be for the amount of clusters that are right now. So we kind of do like a walk around like the hue of an HSV, depending on the number of clusters. And so here we're kind of saying, hey, if the number of cluster colors that we have is not the same as the number of clusters that are in the dataset, reset the colors. Okay, so that makes sense to me. So then, like, how are we ending up with 2 clusters that are of, like, the same fucking color? Oh, I know what it is. It's that we are walking the hue circle, and we are breaking it down into. So if there's like 4 clusters, we are going like hue is equal to I over num clusters minus 1 times 360. So I think that what's happening is like the minimum and maximum values are both ending up at like 0 and 360, which are at the same fucking point. This needs to be divided by something like 360 minus 1 cluster distance. So like something like this. Maybe. Let's look. Oh, fuck. Okay. So, step. So, here we have 2 colors, 2 random colors. Yeah, okay, I think, no, these 2 are still very similar. What's happening here? Can we print out, maybe what we'll just do is we'll just, console log cluster colors here. Div by num clusters instead of num clusters minus 1. Is that right? It might be. I think you're probably right. I think I was doing minus 1 because ID should never match the top one, but maybe you're right. Yeah, that does look better. That does look better. Okay, let's reset. 4 clusters. 1 step. 2 step. So what happened here? So right now we have 3 clusters. Oh, but our coloring is just fucked again. Although now every time I refresh, I get red, green, blue deterministically, which kind of makes me think that there's like a bug in not resetting at the right time. That's okay. Okay. So here also, there's pretty clearly to me a bug in the selection here, right? Like these two are like way better candidates for splitting than this guy. So it would be interesting to maybe like step. We have 3. Step. Here we have 4, but yeah, there's something wrong with after we step, it feels like the color selection is getting fucked. So on next, we fetch next, and then we re-render, and on re-render, we fetch this, we await the data. What are you referencing? I'm not even sure what you're looking at. Right, so we have like 4 sets, we're like generating like clumps of data. And we're trying to create an algorithm that like discovers the clumps. And so what we just implemented was an attempt at hierarchical splitting. So what it's supposed to do is it's supposed to say, hey, let me find a point that's the worst, like farther from every other point. Oh, wait, maybe this is right. So it like picks a point, and what it's supposed to do is it's supposed to say, hey, let me find which points are the best candidates to be in a group with that point. And then what it's doing, we're trying to like color the things to like be relative to like the groupings that we found. So like this is kind of like an okay looking case. This green point should probably be part of this red clump. So there's like maybe it's a bug on which points we're pulling into the new segment as well. I don't know. I was thinking the line should be original, like with just the -1 removed. Yeah, let me think about this again. So, say we have 4 clusters. We're expecting the values. Well, if we have 3 clusters, we want 0, 90, 180, 270. These are all 90 degrees apart. So if we have 4 clusters, that's what we want. So here, say we have 4 clusters. We have 3 over num clusters. 3 over num clusters times this should equal 270. Oh yeah, so this should just be this. 360 over num. So, because we're never going to end up with 4 out of 4. So here we just, yeah. Okay, so I out of, yeah, that seems right. What did I fuck up here? Oh, oops. Divide by num cluster shouldn't happen. There we go. That looks right to me. The simple thing. The first thing that I would have written looks like what I think is now correct. Yeah, okay. That looks right. Okay. So let's reset again and hit step. Might be working. Step. What the fuck, man? Okay. Console log resetting colors. Like, there's something in here with the coloring that's just like so obviously broken, specifically on when we step, not when we actually reset. So we reset the colors here. Oh, we don't fucking clear it. I'm a fucking idiot. Cluster colors equals this. We have to, before we do anything, we have to clear it. That's probably what it was. Okay, reset. Step. All right, that's looking maybe pretty okay. This is obviously fucked. So whatever's happening here, where it's deciding to jump into this cluster instead of one of these, is fucking broken. We just crashed the server. Refresh. But, okay, let's go back to the Diana cluster. So definitely that was working okay. Let's go back to maybe small cluster radius, more clusters. Even smaller cluster radius. Okay, step. Makes sense. Also makes sense. I think that it's like maybe like it's getting confused about like the new versus the old cluster, maybe it feels to me like it's selecting like the wrong side. So like if like, how do I say this? I find like the most dissimilar point to everything else, and when we're bisecting, if I fuck that up, it's okay. But as there becomes more options, fucking that up I think has like a bigger consequence, and especially when we start seeing it like really dig into this same thing over and over and over again, it's like we have like the condition backwards. If that makes sense. Okay, let's look at the algorithm again. So, overall algorithm. We start here. We say, hey, let's look at what it's supposed to do. It's supposed to find the cluster with two objects that have the largest diameter. So we're looking for the distance between every point in our cluster. We're looking for the fucking one that has the, like, what's the biggest distance between 2 points in our cluster? And then pick the thing that has the biggest distance. And this is what I feel like we're fucking up. So let's look at that. So here we say, hey, we go through every cluster, and we look for the maximum distance between points in this cluster. And if the distance is bigger than the max cluster distance, then we assign it. Okay, that's not crazy. And then on our first iteration, we are saying, hey, pick the first cluster, find the maximum points between points in that cluster. Are we off by 1 here? We are. This should be a 1. Because we already did the first cluster, and then we're using this cluster ID, so it needs to start at 1. So that could have been it. That could have been it. If that's the only bug, like the only major bug, that would be so fucking cool. Like, man, would I be so happy if that was the case? 1, 2, 3, 4. Oh, baby! Let's fucking go! Look at that! Oh, it's beautiful! It's beautiful, look at that! That's so sick, man! Holy shit! Boom, 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 boom! Oh, that's so sick. Okay, now let's compare that to the agglomerative cluster, and we'll take like maybe like 5 steps at a time. So this guy's going from the bottom up, and he gets kind of like a similar ancillary at the end, which is kind of cool. Kind of cool. But I like the way that this one feels. It just feels so nice. Okay, so like, what's the stop condition difference between these guys? Top down, I guess you could have like okay, so bottom up, you're kind of saying at some point the distance between the smallest set of points is going to get so large that I don't want to continue anymore. Where like going top down, you would kind of want to go like the next thing that the thing I split out, it had like pretty low density, so I don't really want that anymore. I don't want to split anymore. Or you could say that you have like a number of splits that you're expecting to make. Maybe that's another option. Are you making your own clustering algorithm or implementing an existing one? So right now we're kind of starting with, right now I'm just going through common clustering algorithms on Wikipedia and implementing them. The idea here is not necessarily that we're going to end up using a particular clustering algorithm, but just that like it's good to kind of have a feel for like the different approaches, right? Because like we're kind of like a lot like neural networks where it's just like we take in info, we see things, and then we try to like construct things out of the things we've seen before. And so like exposure to more things, I'm kind of hoping will result in better options on like this type of problem, right? Like depending on what types of solutions we see, that'll kind of affect what approach that we want to take to say, how do we bisect this between dark and light pixels? That's kind of really like the extent of what's going on here. So we'll see. I imagine that probably what will end up happening is we'll find an algorithm that fits this pretty nicely, and then we might adapt it a little bit to handle like noise and stuff. Like, okay. So this is a long stream, 2.5 hours. But I think we're gonna call it there. I guess what problem do you want to solve for clustering? I'll answer you because it's interesting. It's nice to recap this at the end. So just for those of you who are jumping in a little late, we were working on like this like QR code reader, right? And we have this like kind of situation where we work with perfect data, right? So we have this thing, it's perfectly axis aligned. Its blacks are black, its whites are white. And we're doing things like trying to figure out where in this image the finders are, walking these codes and saying like, okay, once we know kind of like the distances between objects, well, first of all, we need to figure out the distances between objects. We do by kind of like analyzing this row and this row here. They're supposed to have like alternating blacks and whites. And then we like kind of walk this thing. We say like, well, is this like area white or is it black? All of those things are affected by noise, right? So imagine that our timing data has some imperfections as we walk. We might accidentally find one or two distances between objects that are way higher than the rest. Or if we're trying to find the finders, we might end up accidentally matching something over here that isn't really part of the finder. And we now like all of a sudden our like perfection assumption that like we're only ever going to find points that are parts of finders is like not true. So we're looking at clustering as an attempt to say, when we're working with real world data, we're taking samples of things, like for instance, this grainy fucking image that isn't really white or black. How do we take these samples of points that we're looking at and then turn them into like discrete concepts of things that we actually care about? So we're looking at clustering algorithms to say like, hey, one example of this is we can look at this histogram and say, well, which of these things are white and which of these things are black, right? And so you could like in our example, probably it's like white is the top, like this area of the histogram, and dark is like this area down here. So when you look at the whole thing, you need to kind of like bisect here and say like this stuff that we see over here, this is dark and this stuff is light. Stuff like that. Yeah. So I think I'm happy with that progress today. I'm really pleased. I really thought I was going to have to debug the algorithm more. But it does feel like it's kind of working okay. And that's pretty fucking cool. What's your take on the curse of dimensionality? I don't know what that means. That's my take. Today's stream demonstrates why off by one arrows are in the three top most difficult. Dude, I fuck up off by one all the time. The other one that I get wrong all the time, which is like really embarrassing, is if you're trying to find like a max value of something and there's something where I like reverse whether or not I should look for minimum or maximum all the time. I'm trying to think of like what the case is. I can't remember, but I fuck up like whether or not I should be using min or max all the fucking time. Okay, sorry. So, long stream. We're going to call it there for the day. Thanks for watching, guys. If you like what you saw, we're streaming most days at around 2 o'clock Pacific time. So it's 4:30 Pacific time now. So if you're watching live, around 2.5 hours ago is when we start, and around 4 usually. There's a YouTube link and a GitHub link in the Twitch description. Where YouTube has like playlists for previous projects. You'll see things on there like Rust operating system, virtual file system, neural network, a little bit of like very tiny amounts of web development, like terminal emulator, Git GUI, diff algorithm, like stuff like that. So if you're interested in any of that, that's there. GitHub has all of the same stuff, but in code. And if you don't see the links, then it's the same username everywhere. If you're watching on YouTube, there should be a Twitch link in the YouTube description. And if you want to swing by and say hi, you can. Cool. I think I have a problem with the clamping values. Yes, it's clamping. I fuck up the clamping on Minimax every time. That's what it is. Yeah. All right. Cool, guys. Thanks for watching. Catch you in the next one. Bye.